Good morning, fellow programmers. Thanks for joining me. I'm T-Pain, and welcome to Let's Learn Python. Feel free to use the skip ahead feature on the right-hand side to jump to any specific sections or examples. Today we'll be using Python 2.7.6 and Python 3.3.3. You can download them from python.org/get. The code we produce will work on both of these versions of Python. Today we'll be focusing on multi-threading, and this will build heavily on past lessons, so feel free to go back and watch them again if anything is unclear. Alright, so multi-threading, what is it? Well, for starters, it has nothing to do with sewing. I know, it's hard to believe. It's a terrible joke. Well, you know how you can run multiple programs at once, like Firefox, Skype, Thunderbird, Photoshop, all of them at once? That is accomplished typically through multi-threading. Multi-threading is running multiple tasks in parallel to each other on the CPU. Most CPUs nowadays have at least a dual core or quad core, sometimes many more. If you have only a single core, I am so sorry. And each of these cores can run many threads simultaneously within them. Think of a thread as simply a process or task that it's executing. Be warned, when you decide to multi-thread, you typically add difficulty to the programming task at hand. Personally, I find that Fabric Softener helps a little bit. Har. So where do we use multi-threading? We will use them on processes that are pretty much independent of one another. For example, you could be making a game that have physics and collision simulation calculations running on one thread, while you have the graphics calculations to display the image on another separate thread. These are two independent systems that could run in parallel at the same time. This is a bit tougher than it sounds though, but that's why multi-threading is such an advanced topic. All these threads communicate with one another through the main or master thread that is running the program. So what should we avoid when multi-threading? Well, typically you don't want to use parallel processing or multi-threading in instances where two threads are going to be manipulating or changing the same data. Accessing the same data is fine, but changing it could go wrong. Imagine one thread is running and it deletes some data or variable that exists somewhere else in the program. Then when another thread tries to access it, the whole program crashes. Another instance is when one thread changes a variable type from like an int to a string. That could cause problems too. This is a problem that's pretty unique to Python though, but it happens. So basically, segregate your processes. Alright, so how do we use multi-threading? Well, there's two different modules out there. There's thread and threading. Thread is an older one that was developed for an earlier version of Python, and threading is newer with many more features. We'll be going through two examples using threading. One is simple and one is more practical. Okay, so here I am in Sublime Text, and I'm just going to go through this really small 25 lines of code. And this is in a file called simple_multithreading.py if you want to copy this for yourself. So the purpose of this program is really simple. We have this sentence right here, and what we're going to do is we're just going to have like this simple splitter function that splits up each individual space so that we have all the words in a list, and then we switch them around randomly. And then down here is where we're actually calling the multiple threads and having each thread do its own randomization and outputting it. Okay, so to comb through this line by line, up here we have importing threading. Threading is lowercase, and this is what's going to allow us to do the multi-threading. Then we have the random module, which we're going to be using to generate random numbers down here. Here we're just being passed in words and storing it in a list. We're creating a new list for the new list of jumbled words. And then here in this while loop, all we're doing is we're saying as long as this list exists, we're just going to keep going through and popping out a random word and then adding it to this new list. And that's all. It's just to jumble the words around. Down here is our implementation. Here we have a sentence that says, I am a handsome beast, .word. I thought it was funny at the time. Here we have the number of threads. We can change this very easily to be 3 or 10 or whatever we want. Thread list is going to be holding all of our threads that are created. And then right here are a couple of important lines. Notice that this says starting and this says exiting. The purpose of these is to show you when the program actually starts and ends, but the threads themselves are actually going to be running past the exiting. Okay, and then we have a simple loop. So in this line, we're actually going to be creating a thread, and the way that we do that is by accessing the constructor thread with the uppercase T, and then we pass in target, which is our target function that we created up here, and then we pass in args, and this is absolutely necessary that this is a tuple. So that's why there's this extra comma right there at the end. After that, we call the start function in order to initialize the thread because it's been bound to a function, and we've passed in the arguments needed for that function. And then finally, the thread is going to be running, and then we add it to the thread list. Finally, at the end, we're going to go ahead and print out the thread count to see how many threads are actually running for the application, and then we're going to exit. So I'm going to run Sublime Text by pressing Control B. All right, and it completed. And so if we look at it really carefully, it says starting, and then a handsome M beast a word. This is great grammar. This is exactly what we wanted. So we get our random threads launching, and we called 5 different threads as declared up here. And so there should be 5 different calls, and then all of them are completed, and then we end our program. So these were running very, very fast and executing before we even reach the end of this. So if I go ahead and run it again, notice what happens on this final print statement right here. Thread count is 2, and then it seems to have added in a, like through some sort of printing error, the actual words down here. This is because the threading is starting to overlap and happen at the exact same time as the text. Now, something interesting happens when you run this in idle. So I'm going to go ahead and crack open that file right here. Going to go ahead and right-click on simple multithreading.py, edit in idle, go ahead and run it. And something to note is that the thread count here is 7. Meanwhile, the thread count down here in Sublime was 2. So what's going on? Well, idle actually, or 3.3 runs, I think 2 different threads at the same time. And this thread count, when it was called, it was actually like still running multiple threads at once. So it's important to be aware that when you start calling these threads, that they may run faster than the main program. So you may want to create a simple like while loop or something to keep the main program running before it actually exits. Okay, so that was a simple application of it. It's only 25 lines of code. Let's go to a more complicated example. Now I have this other file created, and it's called producer_consumer_example.py. And this is actually a prime example to use multi-threading, where you'll have a producer and you'll have a consumer. And the producer will, for instance, put plates of food on a table. And then the consumer will come over and pick up plates off the table. And that's it. Really simple to understand. And that's all this program is doing. Is we have a producer class right here, which is going to be creating like these little strings that say ham, soup, and salad. And then down here we have a consumer that's just going to be pulling them from the table, or the queue. The queue could also be a list. It could be any number of things. I just wanted to use a queue because you'll typically be using queues and with multi-threading. All right, so now that we understand what our programming task is, let's go ahead and comb through this. So we're going to be using, again, the module threading. We're going to be using time and random. We're also going to be using queue, and since I want this to work on both versions of Python, I had to use try and except in order to allow us to try to import both versions of queue depending on what version of Python we are using. So either way, this will work on both versions. Okay, we have this producer, and we have like a simple list of foods that we have, and then we have next time, and next time is just basically acting like a timer. And all it's doing is it's basically randomizing the amount of time that it's going to wait down here. So here we have this this variable global queue, and this is basically saying, hey, I know somewhere else in the program we're going to have this variable queue defined there. And that's what we do in the main program, and we're just like defining a queue. And then here is the most important part. We have a loop that continues for 10 seconds. And what we're saying is while 10 seconds have not passed, or there's less time than 10 seconds that have passed, we're going to see if we have passed the current time threshold. And if we have, then we're going to go ahead and randomly get a food from this list of foods declared up above. And then we're going to put it in that queue and then spit out that we're adding that food. And finally, we're just going to reset the timer to an interval of between 0 and 1. That's what this function right here does. Random.random is just going to generate a floating point number from 0 to 1. Okay, So if we scroll down a little bit more, we're going to see the consumer, and it has the timer, it has most of the same code. And the only thing that's really different is that we have to check to make sure that the queue is not empty when we try to pull from it. When the time is met, if there is something in the queue, then we're just going to go ahead and remove that item and then just reset the timer. And this time, like I said, it's to double the amount of random in order to make the consumer a bit slower than the producer. Let's scroll down a bit more. And then we have our call to our multi-threading, and it's really, really simple. First, we check to see if we're in the main file. Then we're going to go ahead and create a queue, create the producer and consumer classes. Then we're going to create the two threads that are actually going to be running the functions. So we access the class, and we're going to be targeting the run function of that one, as well as the consumer class and running that function on this thread. And no arguments are necessary, so we just go ahead and call start. And let's see what that produces. Pressing Control B to print out. And notice it's just printing out a whole bunch of adding ham, adding soups, removing soups, and it's working perfectly. These guys are running in parallel to each other, and so one producer is adding, and then what the consumer is removing. Really, really cool stuff. And that's it. That is all there is to multi-threading. Okay, that's a lie. There is a bit more. And you can read up on the documentation in the description below if you'd like to. So, thank you so much for watching. Great job keeping up. Definitely take a few minutes to investigate these final challenges. You are a brilliant programmer. I'm sure you can do it if you set your mind to it. Some of you have requested that I post up solutions for these challenges, but I'm refraining because I want you to develop your own skills and solutions. There really is no correct answer out there in the field. Leave me a comment below if this helped you. Please do me a huge favor and subscribe to my channel. It would really mean a lot to me. Also hit the like button to show some love, and thank you so much for your support and keep the dream alive.